Right, good morning. So as you can see, the title of the talk is about something called changing tires on a moving car. I have a bit of a confession to make. As a typical software engineer, cars are really not my thing. So this is going to be a very figurative thing. I'm really good at looking into code, but if it comes to opening a bonnet or changing a tire, if the car is not moving, that's probably as far as I'm willing to go. So this is going to be about the software equivalent of this is like how do we make changes to our large applications built over a long time without impacting our users and our customers. So my name is Pierre. I'm an infrastructure and reliability manager at a company called Populo. We're based here in Ireland, but back down in the south in Cork. What we do is we have a team of about 70 engineers, and we are building a platform of services for large enterprises and organizations around the world to help them communicate better with their employees and their workforce, engage their workforce by creating compelling communication campaigns, measure the impact of their campaigns, and essentially having a better engagement of their employees. And where it matters is that going to work? Yeah, awesome. So Populo is a software that's used by users all around the world, like in all the different time zones. Yet, up until about a year ago, this is the type of page that a user might have seen for a couple of hours every 4 weeks. Populo is currently down for a scheduled maintenance. So this is something that we would do like over and over on a on a monthly basis to release an upgrade of our application. It was something standard that we had done forever. And you might be thinking, okay, this is enterprise software, this is employers communicating with their employees. Sure, what's the big deal? Down for a couple of hours, maybe on a Sunday night. But as I said, we started to get bigger. We started having enterprises all throughout the globe. So essentially, you start thinking, well, do you know what? The Sunday night in Ireland is the Monday morning in Australia. There's not really a good time to do an upgrade anymore. But yeah, this is still, an employer sending a financial results message. Maybe this can wait a couple of hours. And then we get messages like this. So there's been a massive earthquake in New Zealand, and I need Populo to send regular updates to my employees. Like, can you advise when the application will be back online? And we're not talking about an unplanned outage here. We're talking about an upgrade that was scheduled maybe 7 days in advance, full notice for the customers. But then again, earthquakes don't really follow maintenance notice, do they? And an upgrade on the Sunday night. This is Monday morning in New Zealand. And now we're not talking about updating financial results. We're talking about people's safety. So that shift in our heads of saying, well, do you know what? That assumption that we had, let's say maybe a few months ago or a few years ago, as to we can take our application down for upgrades every now and again, that becomes to be challenged for like bigger and bigger reasons. So looking back at the bit of history of our system, like the application in Populo, our core application is mostly monolithic. So large, like standard J2E, Spring applications, Spring, Hibernate, like those kind of standard kind of J2E frameworks with a large monolithic MySQL database behind it. About, like I've said, I suppose 10 years ago, we were deploying every 3 to 6 months, so taking the application down for a few hours for that. We were doing it on a Sunday night. And when I say every 3 to 6 months is because there wasn't very much a kind of a cadence for deployments. It was like, okay, well, we have something ready, let's go and deploy it. As things went and agile frameworks and I suppose the agile like methodology started to become more and more important, we started introducing concept of sprints and going and deploying faster. Now, we did hit some resistance already in that stage. When we were deploying every 3 to 6 months, you can imagine 6 months worth of code changes going live at the same time. Usually you're talking about 2 or 3 weeks of firefighting behind it and patches and hotfixes and that kind of things. So then imagine the conversation that we had to have saying, well, we don't want to be doing that every 6 months, we want to do that every month. And everybody has the kind of scar tissue of, oh, every time we release, it's horrible. Do you want to do that more often? That doesn't sound like a good idea, does it? But then we started seeing that while we deploy faster, actually this is a lot less painful because, well, when we do it faster, then maybe we start addressing problems that we have. And When we deploy faster, there's less that we deploy at every single time. So this was something that we wanted to go and increase. Unfortunately, when we get to that 4 weeks mark, like so every month we wanted to release, then we get to a point where, well, if we're going to be down for every month for 2 or 3 hours, we can't go faster than that because people are not and users are not going to accept that. So how do we go faster, because we feel like going faster as well is a good thing, without impacting our users? And there's a scientific research behind this, like DevOps and the continuous delivery. That's not a fluke. DevOps days, mandatory, mentioned to accelerate, and the state of DevOps report. So I think Google Cloud have a stand outside and have a few printouts. If you haven't read it, just go and read it. If you're an engineering manager, just buy a lot of Accelerate books for your teams. That's the one book that needs to be read to understand the value of DevOps and how it actually drives high-performance organizations. And one of the findings that like Nicole Forsgren and Jess Humble and Gene Kim found through their study of organizations is that high-performing organizations deploy 208 times more frequently than low-performing ones. I actually had to update this slide because the last time I did the presentation, it was for the 2018 report. In 2018, it was 46 times. In a year, it's gone to 208 times. So some organizations that are not taking that move, they are being left behind. So just don't wait. That's super, super important. But even if we have that feeling that, and even the research, that deploying more often is better, how do we do it if every time we want to deploy, there's going to be downtime? And more importantly, when we've done that type of deployment strategy of constantly taking the application down, for an application that's been built over 10 years, the architecture is sometimes a little scary to look at. So, like, well, we never really thought about deploying things that way. And one of the funny thing is, Popular is a really good place to work, which means people stay, which means people tend to put up with the status quo after a while. It's like almost, it can't be done because this was architected like that 10 years ago. We keep talking about it. Zero downtime, great idea, but I think it's going to be too hard, we can't do it. Up until someday, my boss, was the head of engineering, who was a bit newer in the company, went to me and said, well, Pierre, I want us to have deployments without impacting customers. Just go and tell me what we need to do. And it was kind of stepping over that line of, that can't be done, to, well, let's go and look at it. Let's look at it seriously. So what we did is, we applied a practice called, or a method called value stream mapping. And we got a number of people from different teams that were involved in the deployment process. And by different teams, I don't mean just testers and developers. I mean people from the production engineering side, people from the customer success side, people from the customer support side, to essentially just go, what is happening when we're deploying our code? From the moment we tell our customers there's going to be a maintenance, to the time where we're actually pushing binaries, to the time where we're actually running tests in the final production environment when it's upgraded. And when you get all these people together, you get a much bigger picture of saying, well, this is not just about my job. My job fits in the full workflow. It fits in that entire picture of, this is all the different things that are happening inside the deployment. And there's always kind of magical moments that happen during those types of conversations, because you realize people don't necessarily understand what others are doing. And quickly, which was something that for years we talked about, after about half an hour, we were able to step back and say, actually, this is not really that hard, is it? If we move this here, if we do that in parallel, maybe we can get to a really good place. And the kind of light bulb moment throughout that conversation was to realize that what we felt was really impossible to achieve was because we were looking at it the wrong way. What we needed to look at was the impact on the customers. And the impact is actually seeing that zero downtime deployments. It doesn't mean that everything is staying up while we're doing an upgrade. It doesn't mean that everything is running the latest version. It actually means that users don't notice when we're doing all of that. It doesn't matter how long it actually takes, so long as people don't know that something is happening. So some of the result of that value stream mapping in terms of the deployment steps, kind of look like this. So this is what our deployment would have looked like before we did any changes. Typically, when we deploy our application, so monolithic application, large Java code base, we kind of wrap this work into a maintenance mode. So like enable a maintenance mode to kind of limit some of the interactions from the customers. So people can still log in, but have limited functionality. They can't do any kind of big operations in the system. That allows us to kind of wait for some kind of in-process work to complete. That can take between 5 and 30 minutes, depending on the load on the system. At that point, the user impact is limited, but we don't have any downtime yet. Then we shut down all the services. We run database migrations, so like the system, there's no applications running in the system, so we're kind of feel safe to say, okay, we're going to run migration scripts here. As you already know, depending on the scripts, depending on the size of the data, the time, it's very hard to predict, so like that could take up to an hour. Then we upload binaries, we upgrade the services, and start the services and wait for them to start up. That entire phase takes in around 15 minutes, and this is our entire downtime phase here. And the biggest thing here essentially is the 60 minutes or like 15 or 60 minutes, or hard to predict database migrations. What we wanted to look at then is what are all those pieces, and really go back and question, why does the application needs to be down for those steps? Starting with the migrations of the database. So how do we keep our application up while we're running all those migration scripts? Because if we already can do that, then we're cutting down the downtime to only 15 minutes, which becomes more acceptable. And that's online database migration or zero-downtime database migration. That's doable by decoupling the application and the database. Essentially, you want the new version of the database, once it's migrated, to keep working with the old version of the code. That's possible if we follow a certain number of rules of backward compatibility. So the changes that we apply to our schemas, they actually need to keep working with the old version of the code, which means no destructive changes to stuff that's in use. Don't delete tables, don't delete columns, don't change the types of columns, all of those kind of things. You can't do them on anything that's in use. But if we want to do that, if we wanted to delete a column, how do we do it? Then we can use patterns like expand contract. I'm going to go through an example, for example, of renaming a column. What would that look like? But then there's another big thing as well, is now we're changing that safety net of saying, I'm going to run my migrations where no application is starting in the database to, I'm going to have live traffic on my database, and I'm going to upgrade and I'm going to migrate those tables. The problem, if you know MySQL, is locking can be a bit of an issue on different types of queries or different types of schemas. So what we did was to detect changes. We started adding in so in the first instance, we started coming up with a set of principles. These are the types of migrations that you can or cannot do because they're going to cause locks. Unfortunately, as you probably know, a set of principles, when it's in a wiki or something, this is working maybe for a month, and after that everybody forgets. And that's not for everybody's best intentions, it's just that we have a lot of things to remember. One cool thing is our SRE team, after realizing that after a deployment that caused locks in the database, said, well, all those rules that you have in here, just give them to us. We'll write a small script and we'll write a small app, and we'll fail your build if you're running any scripts, any migration scripts that are going to be causing locks. And until then, somebody vets that script, and actually this is fine. This script is going to be running on a table that has a small amount of data. It's going to log the table for a second. I'm happy with it. Check and go forward. Then that's taking one of the things out of the equation for the people to have to remember. So going back to how do we do those kind of hard changes that may cause problems of backward compatibility, let's look at a simple example of, I want to rename surname to last name in my kind of users table or something. So instead of just going off the bat and rename it, what I'm going to do is create a new column. So I'm going to create last name. I'm going to keep surname there. I'm going to start writing to both columns at the same time. So we update the code to do a dual write. Then all of those records that were in the previous column, we're going to actually migrate them to that new column name so that we're starting to have those two columns in sync. Once the two columns are in sync, then we start reading from the new one, making the old one deprecated. And finally, we remove it because now that column is not in use anymore, so we can actually apply a destructive change to it. What does it look like in terms of releases? Well, the first release that we do, the first deploy that we do, we start creating the column and doing the dual write. Then we start migrating the records and read from the new columns. And then we have that kind of cleanup releases where we're saying, well, now there's that column that's not in use, I'm going to go and delete it. The challenge here is this is taking a little bit more time. And it's also, we cannot forget about the last step of cleaning up, because sometimes then we're left with columns that are useless. It's like, oh, we forgot to remove it. So there's a bit of workflow to be done in there. Zero downtime migrations database is probably a talk of its own, and there's probably a good few out there. The DevOps for database, like ebook from Baron Schwartz, is excellent on that, about loosening that coupling between the apps and the database. So highly recommend it. And there's a few other talks there. I will be sharing the slides later, so just you'll be able to look at those. So with database migrations out of the way, then our next hurdle was, well, upgrading the apps, deploying the apps. How does that work if we want to be able to do that while the users are still using the app? So what we looked at was rolling upgrades. So instead of shutting down applications and upgrading them and then starting them back up, was there a way that we could apply that same idea of backward compatibility of two versions, like living live at the same time, to our actual services? So what does a rolling upgrade look like in comparison with a full upgrade? So a full upgrade is, let's say we have two replicas of our system, or two replicas of a service that provides some kind of feature. The full upgrade looks like literally we're doing everything at the same time. All the applications are up, we drain the traffic from them, we stop them, we upgrade them, we start them, and then they're up. That part of the upgrade causes downtime. During that entire phase, the feature is not available, or the full application might not be available. Rolling upgrade, on the other hand, means that we're going to be doing that progressively across our system, provided that our applications, like remember the database that changes now means that version n and n+1 can work with the new schema, so we can actually have those two versions coexist. For the first instance, or the first replica, we're going to be doing it the same thing. The difference is, while this is happening, we're keeping the other one up. So that feature or that service is continuously available. And then once the first one is up, we start upgrading the other one. That's an example with 2. If you have 10, if you have 100, it's the same idea. The big principle is to have that feature continuously available throughout the entire flow. But then what about rollbacks? In a way, rollbacks are much easier, because we have now a system where we have that backward compatibility of coexisting old and new version of the system, old and new version of the schema. So if anything, rollbacks are an easier thing to deal with in those types of situations. I would still advise that rolling back is still doing something that is tricky because it doesn't follow your software delivery. If you have a fast delivery pipeline, fix forward is usually much easier to reason about. Then finally, once we got most of those places sorted out for, suppose the database and the rolling upgrades, we got into a next challenge, which is actually having live traffic during a release, doing an upgrade. Release and deployments, they're stressful. Like if some of you are working in kind of operations or systems engineering, they're usually not the most exciting things to do. I know we had a bit of a rotation in the team of who was doing the release on Sundays, and there's a bit of a the kind of a creeping death look of, oh, this is my turn to do it on Sunday, and even if it's 5 p.m. on Sunday and it's only a couple of hours to do, your Sunday is kind of ruined anyway. Like you know that type of feeling, yeah. So, and now we're going to be telling our, like, suppose, like our teams say, well, you're going to be doing the same thing now. Do you know the thing that was super stressful, but now you're going to put users live while we're doing it? It's like, well, I don't really feel super comfortable about that. So there's a lot of empathy to have about when we're doing it, we need to focus about those upgrades to be less stressful. And why are they stressful? Is because there's a lot of manual work, because we don't really see what's happening. When something is happening, we don't really know what to look for, etc. So what we focused on here is making those deployments more repeatable, more visible, and more consistent, so that regardless of whoever was doing it, it was going to be the same. It's going to be the same process, and it'll have the same information. So how did we do that? First of all, is we took the manual aspect completely out of the equation. Everything in the deployment pipeline is in source control. There's nothing in a Word document. There's nothing in a run book, say copy those RPMs or SSH into that machine. It's everything is so using GitLab and Ansible playbooks to say this is how we're going to be deploying our applications. So what that means is everything was repeatable, everything was consistent, because regardless of who was pressing the button, the same thing was happening. And then when it's in source control, then we can review all those changes. And like there was talk about inner source here, there is an aspect of other teams being able to understand what the deployments look like. It's not that kind of mystic art of operations of how we deploy our code. It's actually in there in the playbook, we can see what's happening. And then the fact that there's no manual operation reduces the stress massively for whoever's doing it, because it's like it actually follows a process. And that's an example here on the screen of like one of our pipelines for deploying all our front-end applications. And when we actually lay it down like this, it looks a lot simpler than that kind of scary process. Then the next thing is, things are scary when things are black boxes. Like systems are scary when we don't really know what's happening behind the scenes. So increasing that visibility of the deployments, and through like more and more observability and more monitoring and more instrumentation of our systems, we actually can raise that confidence that even though that was not a manual process, and when we press that button, then we can actually see what's going on. And we see that, okay, the core health checkpoints of the applications are still green. We don't have any saturations of a problem. We don't have any increased error rates. All of those things that actually say, well, now we're going away from F5ing the application to verify that everything keeps working, to now I'm looking at a dashboard and I can see I have the confidence that everything is green and most of my core signals are right. Rolling upgrade processes are much more complicated than standard upgrades. So being able to see the progression of this, saying, okay, I have like 25% of application moved, I have 50% of services moved. That's kind of that one core starting point of a dashboard to see what's going on. So for this, we relied on our existing kind of monitoring platform that we had in place. So Prometheus, Grafana, and the Elk stack as well, to some extent, to provide some of that stuff. And operations work, like again, just like to remember why are we doing this, right? Why are we doing zero downtime deployments? Is the core thing is we want to go faster. We want to deploy smaller things at a time because we want to limit the risk, because it's more efficient to work in small batches. That principle absolutely needs to apply for any operational changes as well. They apply for your product, but they apply for your ops. So throughout that process, we've embraced that limiting risk factor by changing small things at a time. We didn't go overnight and said to our technical support, we're not going to tell customers about upgrading apps. We're going to migrate our databases on a Thursday afternoon when there's loads of live traffic, and we're going to roll upgrade our apps. Instead, we did all those things bit by bit, still keeping that safety net that we had at the start. And that safety net is, we're doing it on the Sunday. We're doing it with no live traffic. And we keep telling customers, look, the application is going to be down. That gives us a lot more room to actually maneuver. And then we started slowly opening those gates. So starting by saying, now, instead of no traffic, we're going to open a bit of limited traffic. But we're going to keep telling people the application is not up. So if they're using it and they happen to have a problem, then we kind of have that thing to step back on. Then as things looked good, we started saying, well, look, we're going to send full traffic to this. We're going to still tell people the applications will be down, but look, if you're using it, you might have a good surprise that it's still up. As things kind of became more and more clear that it was working, we said, well, Sunday night, that's not a great thing. Let's go into do Monday morning early on. For our people in operations, that added a lot of comfort because now you're not on your own at home doing that remotely. You're in the office with the support of a whole lot of engineers, and they're going to be there to help you if something was to go wrong. And as we started doing it more and more during the day, we actually stopped telling our customers 7 days in advance that something was happening, because at that point there was no downtime. The functionality wasn't affected. What we were telling them is there's a general planned maintenance, so you shouldn't see anything. If you see anything, just tell us. So just kind of a small in-app message. So instead of telling everybody, we're telling the people that were online. Up to a point where we're saying, you know what, like we've done that a good few times now. There hasn't been problems. So maybe we just don't tell anything to anybody anymore. And then we get to the case where it's like, no, well, we can move the time whenever we want. Now we can just do that at our leisure at any time that we want. And that's where we were, I suppose, maybe like 6 months ago. And there's one thing that we hadn't really planned in that process is actually who's owning that deployment piece, because a lot of that stuff would have been done by our system operations team. And all throughout, the ownership of that deployment would have been ops. And so about 6 months ago, we actually said, well, you know what, there's only a button to press. We know what's visible. So the developers are writing the code. Developers are the best to understand what the code does in production. Like, there's no reason why they can't own that entire journey up into pressing that button and deploying. Operations are around if that needs to be escalated to an incident, but ultimately then the teams can say, I can do that whenever I want, I can update, I can do a patch, I can release more smaller changes throughout the day. And in terms of timeline, to give you an idea, we kind of started that journey about October last year, and by January we got to the on-demand deploy with nobody knowing. So that this is about 3-4 months of work. And one of the big things was to realize that this was a monolithic application. And even though like we have some part of our architecture that is microservices and containers and all of that, but you don't have to re-architect your system to get there. It's a fallacy to think that you need microservices to go for continuous delivery. You can do it without re-architecting things, and sometimes stepping back, looking at the process, looking at the flow of information helps a lot to do that. So just to kind of want to leave you with that thought, and that core thing that drove that entire project for us was to really realize that big scary thing of a large monolithic application that could not be deployed without downtime was really down to us looking at it the wrong way, thinking that this was a big bang thing, this was too complicated, is that downtime is only meaningful if people are realizing that there's an impact. If we can take things down, so long as the users aren't affected, it's not a problem. So long as the people don't notice, then like you've won that battle. That's me. Thank you very much.
Okay, I'd just like to add a quick special thanks to Pierre in particular, who stepped in only last weekend to deliver this talk today. So big thanks to Pierre for stepping in last minute for us. So we'd like to open the floor to 1 or 2 questions before we break for coffee. So does anyone have a question for Pierre? I see one here.
Hi Pierre, thanks very much. I liked a bit about the database and architecting your database changes so you don't have the downtime. If it was me, say for example, I have 10 servers behind a load balancer. I would like to upgrade one and then test it before I make it live again on the system. How do you isolate it from, or do you isolate it from the external interface before you do the upgrade, or do you test like that? And then also, say you're bringing down one instance to upgrade it, do you kick people off, or what do you do with user sessions, or do you even bother with it? Do you just wait for a quiet moment and throw the switch, or is there an elegance to it?
Okay,
if you know where I'm coming from.
that's actually a very interesting and challenging point. Like I suppose, so the first thing is load balancer and cutting off traffic is, typically like you want to reroute traffic to servers so that you have some so that you don't want to be kind of cutting traffic down for people that are inside an application. So we're using HA proxy, and through the HA proxy APIs, just kind of rerouting traffic to a number of instances, and we upgrade them by shifting traffic. So I don't believe we're leaving HA proxy doing it automatically, or maybe we are, because with health checks you can get that going automatically. Now your next question was about the sessions, and do we boot people off sessions? So that was a big challenge for us at the start of, well, okay, like, are people going to lose sessions, are going to be asked to log in again, and that kind of thing. So we had to do a bit of gymnastics around the order in which we upgrade different things, so that the sessions would persist somewhere, and then that impact would be minimal. So that also led us to remove state as much as possible from our core applications, so that the state, if the state lives in the browser, for example, this is much easier to deal with, because then all we're upgrading is stateless APIs, and the state remains the same inside the browser. There's a few things that we still have to figure out about things like Spring Webflow, and those flows that have kind of execution modes where they store the state in memory. So for that you can use things like Redis, and so extracting out like that state so that your application just becomes just executable code, and anything that's persistent is outside, so like that database, that kind of caching space. So if that answers your questions, hopefully.
Okay, I'm afraid that's all we actually have time for right now, but if you have any further questions for Pierre, I'm sure he'll be out in the coffee station afterwards. So we'll be taking a 15-minute break now if you want to go stretch your legs, have a cup of coffee, and we'll be back in here for 2 further talks before lunch. Thank you.